My name is Peyton Keller, and I'm a sophomore at Paradise Valley High School. Science has always been one of my favorite subjects because it comes to me naturally. Ever since I was a kid, I loved making up my own experiments with whatever I could find, from battery in a motor to plant life in the backyard. Once I reached high school, my favorite class was computer-aided drafting. After completing all the class lessons, my teacher, Mr. Gaudet, would have a small science experiment for me to embark on. That is how I was introduced to the electrolyzer. At first, it was a small kit that had an electrolyzer and a fuel cell with only a few mini labs to show how water is split. I successfully completed all of these labs and began to play around with it. I connected the electrolyzer, which splits water into its two basic elements, oxygen and hydrogen, directly to the fuel cell, which creates energy from hydrogen. I thought that the electrolyzer would produce enough energy to make a steady flow of hydrogen so that the fuel cell could provide enough energy for both LED lights and the electrolyzer. I was trying to have the system run continuously on only a small amount of energy from a battery pack. Which leads me to my question. What if people could use electrolyzers and fuel cells to power their homes forever on only a small amount of water? Hypothesis. If an electrolyzer can produce an ample amount of energy to a fuel cell, the fuel cell will be able to produce enough energy to power a home and run the electrolyzer, creating a never-ending cycle that only requires water. Why burn fuel or use nuclear fission, which creates a huge amount of byproducts that are bad for the environment, when we can use water and electrolyzer whose only byproduct is oxygen? Research. After experimenting with the electrolyzer, I found I was not exactly sure why this was happening. I knew that water was being split into hydrogen and oxygen, but I did not know how. On the internet, I found the source of the splitting of water happened when the positive and negative side of a battery was connected to a PEM, proton-emitting membrane. Once the electrolyzer had an electrical current connected to the membrane, the water begins to oxidize. On the cathode side of the electrolyzer, oxygen is released, and on the anode side, the electrolyzer, hydrogen is released. In this experiment, we did not use the oxygen any further, and it was the only byproduct in this lab. From there, the hydrogen went to the fuel cell. Once the hydrogen reaches the anode side of the fuel cell, it is converted to protons and electrons. From here, the protons pass through the membrane to the cathode side, leaving behind the electrons and creating an electrical circuit. Data: 1 milliliter of water produced. The first 2 minutes were hooked up to a battery pack as a jump start. Observation: with a jump start of 2 minutes from a AA battery pack and 1 milliliter of purified water, the electrolyzer will produce just under 1 volt of energy for about 7.5 minutes. After this point, the energy production sharply drops but continues to produce a small amount of energy. By using 1 milliliter of water, after 15 minutes we had a 243% energy production increase from the 2-minute startup with only a battery pack. Conclusion: with this technology, the world can receive energy in a better, cleaner fashion. Once the electrolyzer is scaled up to a larger size, we can continue to make energy from water with more electrical output. Scale this technology up even more and it can produce enough energy to power a home.